Hello everyone and welcome to this session on data mining using R. So you must have heard of data as one of the important and essential resource in 21st century for all the businesses. So the ability to analyze and act on data is increasingly important to business in 21st century and also keep up with the market to compete in the market and to adapt the quickly changing demands from the customers. The businesses should be data centric and the managers of these organizations may need to understand high volumes of data before they make the necessary decisions for the businesses. Also, researchers from the University of Texas found that companies can generate big financial returns by making just small improvements in the data or utilizing more data, improving the data quality, usability, and intelligence, remote accessibility. So, it can shoot up the sales of the organization to 14.4% if they increases the usability of its data by 10%. So this shows how important data is. So the importance of data processing can increase the productivity and profits, helps in better decision making, helps in creating more accurate and reliable business strategies to boost revenues. So in this session, we will be talking about data mining a lot. Using R, we will be implementing a case study. So without wasting any time, let's move on to the agenda part. So we will be starting by understanding why do we need data mining. Then we'll be looking into what is exactly data mining. After that, processes of data mining, then methods used for data mining, and finally, we'll be working on a case study using R on data mining. This will give you a hands-on experience on data mining using R. So let's move on to the first one, that is we'll see why do we need data mining. So I'll give you a real life use case or scenario of food ordering app. So the owner of a online food ordering company realizes that he's facing revenue losses. So he encounters all the factors, he analyzes all the factors on his own, that the application is fine, the customer service is fine, the notification strategy for getting sales is fine, the marketing strategy is fine, the delivery of the food is fine. So where they are lagging in the business. So here comes a data analyst with a lot of data mining techniques to analyze the organizations or the company's data. So he analyzes all the factors and data of customer service, the application, the marketing strategies, the delivery of the food, and the notification system, the cost of the food. So also he analyzes the market and the competitors in the market, their prices, their offers, and comes to a conclusion that the company is not giving good offers to their customers, and that is the reason that all the customers are going to their competitors and using their application. So the solution to this problem is simple: give the customers a good offer and they will be yours, and you can get a good revenue generation and you can get a good growth by giving them the offers. So this is the visualization and analysis of the data and the finding of the solution to a problem. So you can understand and you can see from this that how much important is data in real life. Now let's move on to the next part, that is what is actually data mining. So going to the definition, so data mining is simply a process used to turn raw data into useful information. So by using various softwares, the companies can look for patterns in the large batches of data. Then businesses, they can also learn more about their customers to develop more effective marketing strategies, increase their sales and decrease the cost, optimize their products cost so that their customers are willing to buy from them. So data mining is basically the process of extraction of data for business, then collect specific business factors to evaluate the data, such as in this use case that we saw of food ordering app. So the various factors can be the notification system, the marketing strategies, the delivery of the product or the food, and the customer service. So these can be the specific factors for evaluating the business model. Then find useful information from the data, then analyze the data to draw some useful insights and make some decisions to optimize the business strategies. Now let's move on to the next part, that is data mining processes. So these are the processes involved in data mining. That it starts from data extraction, then data pre-processing, data mining, extracting patterns, and visualizing data. So we'll start by data extraction. So data extraction is basically extraction of the data from multiple sources in the form of videos, audios, text, image, and it is stored to the databases of the organization. So in the real life, the data is in the form of unstructured. So it is not always structured. It can be found in the form of images, videos, audios, or maybe text. So we need to make it structured for further pre-processing. So the next part is, or the next process is data pre-processing. It consists of cleaning the data, removing the redundancies, and after that removing the missing data, then manipulating the data to understand its variable so that we can understand the relationship and the association between the variables and the data points in the entire data set, and finally transforming data into a readable and understandable format so that machines can understand the data very well and we can work on it so that we can make a predictive model out of it. Now the next one is data mining. So data mining consists of various techniques such as classification, regression, clustering, association rule mining. So the data in various formats, it can be in exe format, CSV format, doc, and various other formats. So it can be, the algorithms are created using the mining techniques such as classification, regression, clustering, and association rule mining. Then the data in the various formats such as you can see in the screen, that is .exe, .csv, doc, xlsx, xls. These data are fed to the data mining techniques or the data mining algorithms to classify the data, make clusters of the data, and apply association rule mining for establishing a relationship or knowing the association between the data. So these data mining algorithms or techniques are used to build a model which, when given a new data set, can predict some outcome. So it is a type of predictive modeling or making a predictive analysis out of the data set. Now the next is extracting patterns. So when the data is fed into the algorithms, it tries to find the relation between the data, tries to extract the patterns from the data so that a useful information can be fetched out of the data that helps businesses to optimize their business strategies, boost revenues, and they can know the glitches in their business. So this is the use of extracting patterns from the data. Now finally, visualizing the data using beautiful graphs and interactive charts so that we can get statistical overview, a statistical number on what we have visualized and analyzed the data. Now the next one is the methods of data mining. So we'll be going to understand few of the methods. So these are classification, association rule mining, outlier detection, clustering, and regression. So starting off with classification. So talking about the field of data management, the data classification is a part of information lifecycle management process, and it can be defined as a tool for categorization of data, and it can help organizations to effectively segment their potential customers. So it is the process of sorting and categorizing the data into various types, forms, or any other distinct class. And the data classification enables the separation and classification of data according to the dataset requirements for various businesses, or it can be for personal objectives also. So it is mainly a data management process. So here is an example. A classification algorithm is first fed with the data of cars and bikes, and whenever a new data arrives, such as you can see, if the data of car, if the picture of car is given to the algorithm, then it classifies it as a car, and if the data of bikes or the images of bikes is given to the algorithm, it classifies it as bike. So this is the sole purpose of classification. So data is managed or data is segmented according to various classes, and so whenever a new data set arrives, the algorithm classifies it correctly. After that comes association rule mining. So consider an example that a customer goes to an e-commerce website and looks for a guitar and he buys a guitar. Then after few months or few days, he also buys a piano and then he buys a mouth organ. So the recommendation system of the e-commerce website records this sequence of orders and associate it with other orders. So suppose if another customers come and they order a piano or a mouth organ, then the recommendation system will also recommend the products as guitar or mouth organ and all of the musical instruments that are associated with it, so that their sales improves. So this helps these e-commerce websites, and this recommendation engine helps them to increase their revenue generation and to shoot up their sales. Then comes outlier detection. So outlier is the data, or over here you can see a graph that here is a set of regular points and one data point is lying outside the set of common slot of the points. So outlier is basically the data which is not lying in the common slot, and here you can see the graph for number of pens and cost. So from this graph you can see that the cost of 20 pens is close to around 1000 or 500 maybe. So this is the cost of the 20 pens. That means the cost of one pen is either 25 or 50. Now for outlier you can see the number of pens are 30 and the cost is 6000. So 30 pen cost 6000. So the cost of one pen is 300 and it is a large cost as per the common slot of the prices of the pen. So this takes the average cost of the pen a little bit higher from the average cost of the common slot of prices. So this is a redundancy in the output of the data, and it affects the predictive modeling or predictive analytics. So we have to perform outlier detection so that we can use the data effectively to make a predictive model. Now the next one is clustering. So clustering is basically making a group of cluster or segmenting a group of customers according to their similarity. So a common real life example that we can discuss is of Netflix. So what Netflix does is it creates a cluster of similar type of content, and the group of people who are watching type of content, and they make a cluster out of it. They create different groups of people that helps them to recommend the type of content they watch. So this is the application of clustering. So in data mining, this technique helps in analysis of various types of customers. Now the last one is regression. So regression is mainly the evaluation or the comparison of change of one value with respect to another. So here is a graph between x and y that measures, or that is showing the data points lying over there, and a linear, you can see this red line that shows a linear relationship between the two. So basically the use of regression is to evaluate or measure the change in one variable with respect to another, to evaluate or to establish a relationship between them. So this is the purpose of regression. So we have understood the methods of data mining. Now we'll move on to the next section.
So what is R? So R is a language developed by statisticians for statisticians. So if you want to perform any sort of statistical analysis, R should be a go-to language. Now R is also a great visualization tool. So R provides packages such as ggplot2 and plotly so that you can create stunning visualizations. Now R is an open source, cross-platform compatible software. So it's just plug and play. All you have to do is install R once and then you can start having fun with it. And since R is an open source software, you can actually modify the code and add your own innovations to it. And being cross-platform compatible, you can actually run the same R code on different operating systems. And the best thing about R is it is a Turing complete language. That is, it can perform any task which a Turing machine can. Now that's amazing, isn't it? And this is what makes R such a powerful tool. So you can do various operations such as statistical analysis, implement machine learning algorithms, and also create stunning visualizations, all with the help of this super language called as R.
Installing R. So you can download R from cran.r project. So let's go to the site. Right guys, so this is our archive network, and as you see we have different distributions of R respectively for Linux, Mac and Windows. And since I'm using a Windows system, I'll download it for Windows and I'll click over here, install R for the first time. And guys, this is the latest version of R, 3.5.1. I'll click over here, download R 3.5.1 for Windows. Right, so we get this dialog box over here and I click on run and the download would start. After installing R, we'd also require an IDE to make our tasks easier. So one such IDE is RStudio. And we can download RStudio from rstudio.com. Right guys, so this is rstudio.com. I'll click on download RStudio over here. And this is the free version. I'll click on download. Again, we have different distributions for Ubuntu, Windows, Mac and Fedora. Again, since I'm using a Windows system, I'll install it for Windows. I'll click on run and the download would start. Right, so I've downloaded and installed both R and RStudio. Now let's open RStudio and have a look at the different windows present. Right guys, so this is RStudio and this is how RStudio looks like. So as you can see, RStudio comprises of 4 windows. So this first window which you see over here is the script window. As the name states, you can do all of your scripting over here. So let's say I just type a equals 3 and then I'll type print 3, right? So all of your scripting goes over here. And if I want to, let's say, add a new script over here, I need to click on the plus symbol over here. I'll select R script and we get a new script. Similarly, if I want to add another script, I just need to click over here. Right, we have another new script over here. Okay. And if I want to save what I've written over here, I need to click over here and this will be saved. Let me give this a name. So I'll just give it some random name. I'll save this. Right. So I've saved this file as sgdsd.r. And if you want to run or execute the code, you have this run button over here. So let me select these 2 lines. I'll click on run. So when we click on run, the code goes to the console window and gets executed. So guys, this was the script window. Now we can actually use the console window here directly to run our commands. So I'll give some commands over here. Let me just run some basic mathematical operations. So I'll type 8 plus 5, right? So this gives us 13. Similarly, I'll type 10 minus 5, which gives us 5, right? So you can directly use the console window to run all of our commands. And over here, what we see is the environment window. So this gives us a glance of all the objects we have stored, right? So till now, we just have one object with the name A, and that is what we see over here. So we have an object A whose value is 3. Now similarly, let's see if I add another object B over here, B equals 10, and I'll print B. Let me execute these 2 lines of code, right? So as soon as I executed these 2 lines of code, what we see is another object has been added in this environment window, right? So initially we just had the object A. After executing these 2 lines of code, another object B has been added along with its value. And now if I want to clear all of these, I can do that by clicking here, right? So this will remove all of these objects over here. Okay. And then we have the history section. So this gives us a list of all the commands which we have implemented till now, right? So this is just a history of all the commands which we had executed. And we have this final window at the bottom right corner. So this window is for installing new packages, visualizing plots, and accessing help whenever needed. Right, so let me give you guys an example. So let me make a histogram. So I'll type hist. I'll type in lynx, which is a data set. So guys, this is the visualization which we get over here. right? Similarly, if we want to install a new package, I'll click over here. I'll click on install, and let's say the package which I'd want to install would be tree. I'll click here, and when I click on install, the package installation would start. And then we have help. So whenever we need any sort of help, we can use this window. So let's say there is a dataset called as iris, which is inbuilt in R. So if you want to know information about this dataset, all I need to do is type the name of the dataset and I'll hit enter, right? So you get all of the information with respect to this data over here. So guys, this is all about RStudio. So now that we've installed R and RStudio, it's finally time to get on with the practical part. So we'll start off by reading data into R console. R provides different functions to read different data formats. So if you want to read a text file, you can use the read.table function. For comma separated files, you can use read.csv function. For reading JSON files, you have the from JSON function. And similarly, if you want to read data from HTML tables, R provides a function called read HTML table. So you can read all formats of data into R. And since our customer churn data is of .csv type, he'll be using the read.csv function. So let's head on to RStudio. So this is RStudio, guys. So I'll use the read.csv function to read the customer churn dataset. Alright, I'll put in the double quotes. Now, this is the dataset, guys. This is the .csv file. I'll click on properties and I'll copy the path from over here. And I'll paste the path. Now, you need to keep in mind that this is actually a forward slash when you're giving the path. Right? And after giving the path, I'll give the name of the file, which will be customerchurn.csv. And I will store this in a new object and I'll name the object to be customer churn as well. Right, so this what you see is actually an assignment operator. So I'm reading this path and I'm saving this file into an object called as customer churn. Right, now let me have a glance at this dataset. So what I'll do is I'll use the view function. So I'll type view and I'll type out customer churn. So this is our customer churn dataset, guys. Now let me use the class function to have a look at the type of this object. So I'll use class and I'll give the name of the object, which is customer churn. So what we see is this object is of type data frame. That is, this is actually a data frame. Now if you're coming from the SQL background, you can say that a data frame is actually sort of a table. So over here, all of these columns are of the same data type and each row represents a record of this data frame. Right, so let's say if I select this column tenure, then this will be of one particular data type. So let me go ahead and see what is the type of this. So I'll use class and I'll type customer churn dollar tenure. So I see that this is of integer type. That is, this tenure column is of integer type. Now another thing that you need to keep in mind is all of these columns are actually vectors and factors. That is, a vector is a set of homogeneous entities and a factor represents categorical values. So now let me type out class and what I'll do is I'll type out customer churn dollar gender. So I get that the class of this object is factor. Now what we see over here is this just has two categorical values, female and male. So whenever we have just categorical values, then most probably the class of that column is of factor, right? So we've understood what a data frame is and we've also had a look at vectors and factors. Right, now we'll go ahead and understand how can we access individual columns from this data frame or access individual elements from this data frame. Now, let's say I would want to access the column device protection from this entire data frame. So how can I do that? Well, it's actually simple. So what I'll do is I'll start off by giving the name of the data frame. It should be customer churn. Then I'll use the dollar symbol and I automatically get a list of all of the columns. And since I need the device protection, I will type DEVI. I'll select this and I'll store this in a new object and I'll name this new object as C underscore device protection. Right, so let me have a glance at this actually. So I'll type view of C underscore device protection. So what I've basically done is from this entire data set, I've just selected this column and stored it into a new object and named that object as C device protection. Right, so similarly, if I want to select the payment method column, I can do the same thing. So what I'll do is I'll type out the name of the data frame. I'll use the dollar symbol and I'll type the name of the column, which will be payment method over here. And I'll store this in, let's say, C payment. Now let me have a glance at this. So I'll type view C underscore payment. Right, so I have separated this column from this entire data set. Right, so this is one way by which we can select individual columns. We can also use the second method. So the second method is also simple. So what we'll do is we'll start off by giving the name of the data set. Then I'll give the square braces. Now inside the square braces, the values which are on the left side of the comma represent all of the rows, and the values which are on the right side of the comma represent all of the columns. Now let's say I would want to select this gender column. So what I'll do is I'll just give the numbering of the column, that is at which position the column is present. So I'll type out 2 over here and I'll save this in, let's say, C underscore gender. Now let me have a look at this. So I'll type view C underscore gender. Right. So I have used the square braces to select the second column from this customer churn dataset. Now, similarly, if I want to select the first column, I can do the same thing. So what I'll do is I'll just put 1 over here and I'll name this object as C underscore ID. Right. So let's have a look at this view of C underscore ID. This is the column which gives me the customer IDs. Right. Now, we can also select multiple columns in the same way. So let's say I would want to select the second, sixth, and seventh column from the customer churn dataset. So what I'll do is I'll put a comma over here. I'll use the combine function, right? And I'll give all of the columns that I want to select. So I need the second column, the sixth column, and the seventh column, right? And I'll store this in C underscore 267. So let's see what is the result now. Again, I'll type view of C underscore 2, 6, and 7. Right, so I have successfully selected second column, sixth column, and seventh column. So let's actually verify. So yes, this is the second column, 3, 4, 5, 6. So 6 is tenure, 7 is phone service. Right, so we have sixth and the seventh column. So this is how we can separate out some specific columns from the data set. Let's say I would want these two columns over here. So I can actually type out the names of those columns. So what I'll do is I'll type monthly charges and I'll save this in C month. So let me have a look at this view of C month. Right, so I have successfully selected out the monthly charges column. Now I can also select a set of continuous columns. So let's go and do that. Now let's say I would want to select all of the columns from senior citizen to multiple lines. That is from column number 3 to 4, 5, 6, 7, and 8. So I would want all of the columns from column number 3 to column number 8. So let's go ahead and do that now. So for that, what I'll do is I'll type the name of the data set. I'll put a comma over here. I'll put 3, and from 3 I'll use colon symbol. I'll just put out 8 over here. So this will give me all of the columns starting from the third column to the 8th column. So let's say I will save this in C underscore 38. So let me have a look at this now. View of C underscore 38. Right. So I have successfully selected out all of the columns from 3rd to 8th. So the 3rd column is senior citizen and the 8th column is multiple lines. Right, now So this is how we can filter out some specific columns. So if we wanted to filter out some specific rows, so let's go ahead and understand how can we do that. Now, as I've already stated, if you would want to filter out rows, we would want to give it on the left side of the comma. And if you would want to filter out some specific columns, you would want to give it on the right side of the comma. So let's go ahead and filter out some rows. So now let's say I would want the second row of this data set. So all I need to do is type in 2 over here, and this will give me the second row. Right, so let me store it in C underscore, and let me have a look at this. View of C underscore 2. Right, so this is the second record whose customer ID is 5575. So let me just verify. Right, so this is the second record over here, and this is the same record that we have successfully filtered out. Similarly, let's say if I would want the record or the row number 100, so I'll just type out 100 over here, and let me store this in C underscore 100. Let me have a look at the result. View of C underscore 100. Alright, so this is the record which is placed at the 100th row, whose customer ID is this. Now we'll go ahead and understand how can we filter out multiple rows from this. So let's say I would want the first, fifth, and the 10th row. So I'll use the combine function over here, and I'll give all of the row numbers. So I need the first row, fifth row, and the 10th row. And I'll store this in, let's say, 1 underscore 5 underscore 10. Alright, so let me have a glance at this. I'll type C underscore 1 underscore and this. Right. So I have successfully filtered out the first, fifth, and the 10th row. So see that the gender of the customers at first and fifth columns is female, and the gender at the 10th column is male. Now what we'll do is we'll filter out a sequence of rows. So let's say I would want all the rows from let's say row number 100 to row number 200. So what I'll do is I'll type 100 to 200, and I'll store this in C 100 200. So let me have a glance at this. I'll type view of C underscore 100 200. Right, so this gives me 101 entries starting from row number 100 to row number 200. Right, similarly, let's say if I would want all of the rows from 10,000. So similarly, let's say if I would want all of the rows from 5,000 to 7,000, we can also do that. I'll just simply put over here 5,000, and then I'll type in 7,000 over here. Right, so let me just type out 5,000, 7,000 over here. Let me have a glance at this. So I'll type view of C underscore 5,000, 7,000. Right, so there are 2001 entries starting from row number 5,000 to row number 7,000. Right. Now what we'll do is we'll give out both the row numbers and the column numbers. That is, we'll filter out some specific rows and some specific columns. So let's go ahead and do that. Now let's say I would want the row numbers from 50 to 60, and I would want just the second and the third column. So let's go ahead and do that. So the row numbers from 50 to 60 and just the second and third column. So I'll use C2, 3. And let's just store in C random 1. Let me have a glance at this view of C underscore random 1. Right, so this gives me all of the records from row number 50 to row number 60, and I've just selected these two columns, gender and senior citizen. Now let me actually go ahead and complicate this a bit. So let's say I would want row numbers from 100 to 200 and also from 1000 to 2000, and I would want the columns 2, 3, 5, and 7. So let's go ahead and do that now. Right, so I'll use C over here. First part would be where I need row numbers 100 to 200, and I would also need row numbers from 1000 to 2000. Right, so this is my first part where I'm filtering out all of the rows, and I would need column numbers 2, 3, 5, and 7. So let me go ahead and put down all of these column numbers, and let me store this in C underscore random 2. So let me have a look at this view of C underscore random 2. Alright, so I have 1102 entries in total, where I have rows from 100 to 200, and as you see over here, just after row number 200, the row number gets to 1000 because I have filtered out all of the rows from 100 to 200, and then it starts from 1000 to 2000, and I've selected column number 2, 3, 5, and 7. Right. So this was an intro to our data frames, vectors, and factors, and how can we access individual elements from the data frame. We're going to look at the various types of operators in R and implement them on the customer churn dataset. So broadly speaking, these are the operators. We have assignment operators, arithmetic operators, logical operators, and relational operators. So let's go to RStudio and work with all of these. So we are back to RStudio, guys. So now to work with assignment operators, what I'll do is I'll start off by loading the customer churn dataset, and I'll use the read.csv function for this. I'll put in double quotes, and let me go ahead and copy the path of this dataset. So this is the dataset. I'll go to properties and copy the path. I'll paste it over here. Again, this needs to be a forward slash. So I'll change this backward slash to a forward slash. And I'll go ahead and give the name of the dataset, which will be customer churn.csv. Now what we'll do is we'll give an assignment operator. So this symbol which you see over here is nothing but an assignment operator, which helps us to store values into an object. So using this assignment operator, I'll store this customer churn.csv file into an object, and I'll name that object to be, let's say, churn1. Now similarly, there are two other ways by which we can use this assignment operator. So I'll copy this. I'll just clear this window first. Right. And now I can actually give the name of the object first and then use this assignment operator. Right. So this is less than symbol hyphen. It's the same thing. So I am basically loading this path into this object using this assignment operator. Right. So let me have a glance at this. I will type view of churn2. Right. So we have our data set now. Now instead of using these two operators, I can also use the equal to operator. So I will change this to churn3 now. And when I have a glance at this, this will actually be the same. So churn1, churn2, and churn3 are actually the same data sets, but I've just used different assignment operators to store them into these objects. Right, so these were the different assignment operators. Now we'll go ahead and work with arithmetic operators as well. So arithmetic operators simply are plus, minus, division, and multiplication. So now we'll be implementing all of those arithmetic operators on top of this customer churn dataset. So you see these two columns over here, monthly charges and total charges. So I will be using the arithmetic operators on top of this. So I will take this cell over here. So let's say this customer's monthly charges is 29, but actually what happened was there was some calculation error and his monthly charges was just 28.85. So we'll go ahead and change this value to 28.85. So how can we do that? So for that, all we have to do is subtract this cell value with 1. So let's do that. So I will select churn1 dollar, and I'll select the column name, which is monthly charges. Since this is the cell which is the first row, I will give out 1 over here. So from this cell value, I need to subtract 1. Right, I have subtracted 1. Now I'll store this result back to the same cell. So I'll type churn1 $monthly charges, and the cell is obviously 1. Now let me have a glance at churn1 dataset. Let me go to the monthly charges column. Right. So here is the difference. So initially the value was 29.85. We have rectified the error, we have subtracted 1 from it, and now the value is 28.85. So similarly, we will be using the plus operator. So plus operator basically helps us to add something to the predefined value. Again, so let's see the second customer over here whose charges are 1889, but again this was incorrectly calculated and his charges were 1890. So we'll just add that 1 to this using the plus operator. So let me select that cell. I'll type churn1 total charges, and the cell number is 2, and I'll add 1 to that. After adding 1, I'll store it back to the same result. So I'll type churn1 total charges, and the cell number is obviously 2. So let me refresh this view of churn1. Let me go to the total charges column. Right, so initially it was 1889.50. After adding 1 to it, the total charges became to 1890. Now, let's say there is some discount going on, and randomly a customer gets a discount of 10%. So let's see, it is this customer over here who gets a discount of 10%. So let me see which row number is this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is row number 9 over here, and let's say this customer gets a discount of 10%. So what we have to do is basically multiply this value with 0.9, and when you multiply with value with 0.9, the value gets reduced by 10%. So let's go ahead and do that. I'll type churn1 total charges, and it is the 9th cell over here. I will multiply this with 0.9, and I'll store it back to the same cell over here. So this will be churn1 total charges, and I've given the cell number over here. Right, let me press enter, and let me see what is the result. So view of churn1. So let me go to total charges over here. Right, so initially it was 3046, and after giving a discount of 10%, that total charges came down to 2741. Right, so let me show it again. So it was initially 3046, and after discount of 10%, it was 2741. Now similarly, let's say a customer gets a discount of 50%. So all you have to do is divide that value by 2. So let's say it is this third customer over here who gets a discount of 50% on his monthly charges. So let's go ahead and divide that cell value by 2. I need to select churn1 monthly charges, and cell number is 3. I will divide that value by 2, and I'll store it back to the same cell. So that will be churn1 monthly charges, and cell number is obviously 3. So let me refresh this now. View of churn1. Right, so initially the monthly charges were 53 over here, and after giving a discount of 50%, his monthly charges came down to 26. So from 53 to 26, a discount of 50%. Right, so these were arithmetic operators. Now we'll go ahead and work with relational operators. So relational operators basically help us to find out the relation between them, such as which one is greater, which one is lesser. So now let's say I would want to find out all of those customers whose tenure is more than 60. So let's go ahead and do that. So for that, I will type churn1 I'll select the column which is tenure, and I'll just use the greater than operator. That is churn1 tenure is greater than 60, and I'll store this in, let's say, C tenure. Right, So let me have a glance at this now. View of C tenure. Now these are just false and true values. So what basically this means is, so wherever you see false, this means that the tenure is not greater than 60. And you see this true value, it means that the tenure is greater than 60. So let's see, let's actually verify this. So this is the tenure over here. So we see that this is the only value where tenure is greater than 60. And we have a true value for that, right? So now if we actually want to clearly see the values wherever the tenure is greater than 60, we can use the subset function for that. So I'll use subset. I'll give the name of the data set first, right? So from this data set, I need all of those values where C of tenure is equal to true. And I'll store this back to C of tenure. Now let me see what is the result. Right, so we see there are 1407 customers whose tenure is more than 60. So you see this over here. So these are all of the customers whose tenure is more than 60. And we found that out using the greater than operator. Right, now similarly we'll use the less than operator to find out all of those customers whose monthly charges are less than $10. Right, so I will type churn $1 monthly charges, and this needs to be less than 10, and I'll store this in C mon. Right, so let me have a glance at this. C underscore mon. And now let me use the subset function to find out the actual values. So I'll type subset, I'll give the name of the data set. I'll type out CMON over here, and I need all of those values where this is true. Right. I'll store this back to CM of n. Now let me have a glance at this. C underscore M of n. So see that there are 0 entries. That is, there is actually no customer whose monthly charges are less than $10. Right, so this was the greater than operator and less than operator. Now we'll go ahead and also work with logical operators. So logical operators are basically and or. So these basically help us to give multiple conditions. So let's say I would want to select all of those customers where gender is male and senior citizen is 1. So we can do that using the AND operator. So what I'll do is I will type churn $1 gender, and I'll keep this to be male. Now I'll use the AND logical operator. Now I will need to select all the senior citizens. That is where churn $1 senior citizen is double equal to 1. Right. And I will store this in, let's say, C underscore ms. So let me have a look at this. So I'll type view C underscore ms. Now let me use the subset function to find out the real results. Subset churn 1 C underscore ms is double equal to true, and I will store this back to C underscore ms. Now let me have a glance at this. Right, so there are 574 entries or 574 customers whose gender is male and who are senior citizens. Or in other words, there are 574 senior male citizens. Right, so this was the AND operator. Now we'll go ahead and work with OR operator. So let's say I would want to select all of those customers whose internet service is either DSL or fiber optic. So let's use the OR operator for that. So what I'll do is I'll type churn $1 internet service is either equal to DSL. Then I'll use the OR logical operator. I'll type churn $1 internet service equals fiber optic. That is, I will get the list of all those customers who use either of these internet service, and I'll store this in, let's say, C underscore internet. Alright, so let me have a glance at this. I'll type C underscore internet. Now let me use the subset function to find out the result. I'll give the dataset name, then I'll type C underscore internet and find out all of those values where the result is true, and I'll store it back to C underscore internet. Right, so I see that there are 5,517 customers whose internet service is either DSL or fiber optic. So we are done with the OR operator and operator. Now we'll also go ahead and work with NOT operator. NOT operator basically gives us the contrasting value. So let's see, we'll work with the senior citizen column, and I would want to select all of those rows where the senior citizen value is 0. So you can use the NOT operator for that. So what I'll do is churn1 $senior citizen is not equal to 1. That is, so I will get all of those values where this value is not equal to 1. And since the only other value is 0, so I'll get all of those rows. And I'll store this in, and let's say C not senior. And let me have a glance at this. Right. So let me use the subset function, subset of churn1, and I'll give this to be double equal to true, and I'll store it back to C not senior. Let me have a glance at this again. View of C underscore. Right, so there are 5,901 customers who are not senior citizens. Right, so we've worked with assignment operators, arithmetic operators, relational operators, and logical operators. We're going to look at the various types of inbuilt function in R and implement them on the customer churn dataset. So these are some of the inbuilt functions. So let's go to RStudio and work with them. So we'll head back to RStudio. Let me just have a glance at the dataset first. So I'll type out view of customer churn. Right, so this is a data set. So we'll start off by understanding the structure of this data set. So for that, I'll be using the structure function str, and I'll give in the name of the data set, which is customer churn. Right, so this function gives me the entire structure of this data set. So this basically tells me that I'm working with a data set where there are 7,043 observations of 21 variables, or in other words, there are 7,043 rows and 21 columns, and these are all of the columns over here. So we have customer ID, gender, senior citizen, online backup, streaming movies, churn, and so on. Right, so now followed by the name of the column, we also have the data type or the class of the column. Right, so over here we see that customer ID is of type factor, gender again is of type factor, senior citizen is of integer, and these are the values. So the values are either zeros and ones, right? And over here multiple lines is of type factor with 3 levels. So these are the 3 factor levels over here. So it could be either no, yes, or no phone service. And then similarly we have the internet service with the 3 factor levels. So it could either be DSL, fiber optic, or no. Right, again, so for contract, we have 3 factor levels, which could be either month to month or 1 year or 2 years. Right, so we have found out all of this with the help of the structure function. All right, now we'll go ahead and implement the second inbuilt function. So we'll be using the head function for this. Right, so head function basically gives us the top 6 records of the data set. Right, so I will just go ahead and give the name of the data set over here, head of customer churn. Right, so this has given me the first 6 records. So we have the first 6 records for all of the columns over here. All right, now if I want to have a look at the first 10 records, all I'd have to do is give a number over here. So now I have the first 10 records of the data set. So similarly, if I just want to have a look at the first 2 records, I'll just give the number 2 over here. Right, so I can have a look at the first 2 records of the data set. So similar to head, we have another function called tail. So tail function gives the last 6 records of the dataset. So I'll go ahead and give our customer churn dataset over here. So you can see the row numbers over here. So they start from 7038 and they end at 7043. So basically this tail function gives us the last 6 records of the dataset. Similarly, if I just want the last one record of this dataset, I'll just give the number 1. Right, so this is our last record. So row number 7043. Similarly, if we want the last 10 records, I'll put 10 over here. Right, so it starts from 7034 to 7043. So these are the last 10 records of the dataset. Right, so we are done with head, we're done with tail. Now we'll use end row and end call to find out the number of rows and number of columns. Right, so I'll type end row and I'll give in the name of the dataset. Right, so with this we find out that there are 7043 rows in this column. Similarly, I will type end call and I'll give the name of the dataset customer churn. Now we find out that there are 21 columns in this dataset. Right, so now we have some numerical columns in our dataset. So we have monthly charges and total charges. Now what if I would want to find out the mean values or the maximum values of monthly charges? So let's go ahead and do that. So let's say I would want to find out the mean of monthly charges. So all I need to do is type out mean over here and then give the column over here. So I'll type customer churn dollar. I'll select the column which is monthly charges. Right. So the mean of monthly charges for all of the customers is around $64. Similarly, if I'd want to find out the minimum of monthly charges, I'll type out min. I'll give the name of the dataset and then I'll type out monthly charges again over here. Right, so the minimum monthly charges are $18. Similarly, if I want to find out the maximum of monthly charges, I'll type out max. I'll give the name of the dataset, which is customer churn, followed by the name of the column, which is monthly charges. Right, so the maximum is $118. So similarly, what I'll do is I'll find out the mean, max, and min for the total charges as well. Now we also have the range function, which automatically gives us the minimum and maximum values. So I'll give range over here. I'll type the name of the dataset, which is customer churn, and I'll select the column which is monthly charges. Right, so range gives me the range of all of the values. So the minimum value is 18 and the maximum value is 118. Now, so let's say there's a lucky draw going on and we are selecting 5 customers randomly to give a discount. So we can use a sample function for that. So with the help of sample function, I'll be selecting some 5 random customer IDs. So let me go ahead and do that. I'll type sample and what I'll do is I'll select the customer ID column and I'll give the number 5. That is, from the entire data set, we are selecting 5 random customer IDs. Right, so these values which we see over here, so these are the customer IDs. So this is the first, second, third, fourth, and fifth. So this has randomly given us 5 customer IDs from around 7043 entries. So again, let's say if I would want around 20 random customer IDs, I'll give the number to be 20 over here. Right, so these are all the 20 customer IDs. Now next, if you would want to find out the distribution of some categorical variables, then we can use the table function. So over here we see that we have a lot of factors over here. So gender is a factor column, partner is a factor column, internet service is a factor column. So most of these are actually factor columns. So now if we have a lot of factor columns, we can use a table function to find out the distribution. So now let's say for this gender column, I would want to find out the number of female customers and also the number of male customers. So all I'd have to do is use a table function for this. So I'll type out table, I'll give the name of the data set, and I'll just select the column over here, which is gender. Right. So this basically tells me that there are around 3,488 female customers and 3,555 male customers. Right. So similarly, if I do want to find out the distribution for internet service, I'll use the table function again. I'll give the name of the data set and then I'll give the column name, which is internet service. Right. So around 2,421 customers use DSL and 3,096 customers use fiber optic, and there are around 1,526 customers who don't use any sort of internet service. Right. Now, so let's say we would want to find out the contract of the customers. I'll again use a table function and I'll type the name of the data set followed by the column. Right. So there are 3,875 customers who have month to month contract, 1,473 customers who have a contract on yearly basis, 1,695 customers who have the contract on a 2-year basis. Right, so next, finally, we'll use a table function on the payment method column. Again, I'll type a table over here. Right, I'll give the name of the dataset, which is customer churn, and I'll select the payment method column. Right, so around 1,544 customers do it via bank transfer, 1,522 customers paid by credit card, and these are the rest of the customers who pay via electronic check and mail check. We're going to work with flow control statements and user defined functions. Now, these flow control statements basically help us to control the flow of execution. So in general, the statements are executed from top to bottom. But with the help of flow control statements, we can manipulate the order of execution. So these are some of the flow control statements over here. If else, and switch are something known as selector statements. Then we have repeat, for, and while, which are looping statements. We also have some jump statements like continue and break. So let's have a closer look at selector statements. As the name suggests, the selector statements help us to select or manipulate data on the basis of a condition, such as if it rains, we'll not play football, or if you're sick, you'll not eat ice cream. So we'll just go ahead and start working with the selector statements. Right, so I'll start off and have a quick glance at our customer churn dataset. I will type view of customer churn, and we have our dataset right in front of us. Now I will start with the if condition, and I will check if this cell over here, the value in this cell is female, and if the test condition comes out to be true, then I'll change this value to be male. So let me go ahead and do that. Right, so I will type if, I will give the name of the dataset, which is customer churn, and the column is gender, and the row number is obviously 1. So from this dataset, I am checking if the value in this column is female. So if this is equal to female, then I will give some action over here. So what I'll do is I'll change that value to be male. I'll give the name of the dataset. I will select the column, and in this column, right, so this is cell number 1, and over here I'll change the value from female to male. Right, so initially we had female over here. Now let me copy and paste it over here. Now let me have a glance at the customer dataset again. Right, so we have changed this value from female to male with the help of the if condition. Right, similarly we'll use the if clause again to check if the tenure over here, so we'll take this cell value over here. So if the tenure is, let's say, greater than 62 months, then what I'll do is I'll give this customer a discount of 10%. Right, so over here I see the monthly charges, and over here we have the customer. So this is customer which presented row number 10, and I will give this guy a discount of 10% for his monthly charges. Right, so let me go ahead and create another if clause over here. So I will type if customer churn $tenure is greater than 50, and this cell number over here is 10. Now this is very important, right? So this is cell number 10. If that value is greater than 50, then what I'll do is I will give a corresponding discount in monthly charges. Cell number is 10. So customer churn dollar monthly charges, cell number 10, and I will give this guy a discount of 10%. And that is why I am multiplying this value with 0.9 over here. So you see, we have taken out this cell value and I'm multiplying that value with 0.9, and that is how this guy will get a discount of 10%, and I am storing back the result into the same cell. Let me copy it and paste it over here. So let's just have a quick glance. So the initial value is 56. Now after modification, let's have a look at the monthly charges. Right, so initially it was 56. Then after using the if clause, we have changed his monthly charges to 50 by giving him a discount of 10%. Right, so this was if. Now we'll go ahead and also implement the if else clause. So we'll use the churn column for that, and we'll be using this cell. So let's say if we'll just check if the value over here is no, or in other words, it basically means that the customer will not churn out, or the customer will be using the same network, then we'll just print that thank you for using our network. And if this is yes, then we will print please give us a feedback on how we can improve our network. So let's go ahead and do that. Right, so if customer churn dollar churn, and this is row number 1, is double equal to yes, and if this comes out to be true, I just need to print please give us a feedback on how we can improve our network. Right, else I will print thank you for using our network. Let me paste it over here and let me see what will be the result. So we get thank you for using our network because this customer does not churn out. Right, so we are done with if, we are done with if else. Now we'll work with the third selector statement, which is switch. So with the help of switch, I will give this guy a discount on monthly charges with respect to the internet service. Let's say I will take this customer, and I will say if this guy uses internet service of DSL, then I'll be giving him a discount of 10%, and if he uses internet service of fiber optic, then I'll be giving him a discount of 20%. So let me go ahead and do this using the switch statement. So I'll delete all of this. I will type switch over here. So over here I need to give the object. So object again. Now since this is actually a factor, I will change this to a character vector. So I will type as dot character of, and I'll give the column over here, which will be customer churn dollar internet service. Right, now the first case would be DSL. As if the customer's internet service is DSL, then I will give this guy a discount of 10%. Right, again, so let me have a glance at the cell numbers. This will be 1, 2, 3, 4, and 5. Right, so over here, let me just give down the cell number, which is 5. So what I'll do is I'll select customer churn dollar monthly charges, cell number is 5, and I'll give this guy a discount of 10%. I'll give a comma. Now I'll give the second case. And the second case is if this guy uses fiber optic. So if this guy uses fiber optic, then I will give this guy a discount of 20%. So customer churn dollar monthly charges, cell number 5, and 20% discount. So I'd have to multiply this value by 0.8. So let me go to monthly charges. So 1, 2, 3, 4, 5. So this was the initial value 70. Right. Now I will select all of this, paste it over here, and I'll store the result back to the same cell. So this will be customer churn dollar monthly charges, cell number is 5. Let me have a glance at the data set now. Let us see the result. So we have our monthly charges. So initially it was 70, and after giving this guy a discount of 20%, his monthly charges came down to 56. Right, so we are also done with switch. Then we have looping statements. So these looping statements basically keep on repeating a certain action, like keep on printing your name for 1,000 times, or keep playing the music for the next 1 hour. Right, so let's go ahead and work with this looping statements. So I'll start with for loop. Now we have this gender column over here, and I'll use the for loop to count the number of male customers. Right, so I will type for, and over here I'll give a variable, and I'll name this variable to be I. This is the vector, so I'll give a range over here. So for I n 1 is to n row of customer churn. So that is, this loop will run starting from 1 to 7043. Right, now in this entire loop I need to check number of male customers. So for that I will use the if condition. So if customer churn dollar gender is double equal to male. Now I will create another variable over here and give this to be 0. So if customer churn dollar gender, again I need to give the cell, which is I over here. So if customer churn dollar gender I is double equal to male, then I will increment the count value. So count will be count plus 1. Right, so what is happening is initially I value is 1, so now this will be evaluated to true, and again over here I am checking if customer churn dollar gender, the first cell value, if this is equal to male, then I'll increment count with 1. Again this loop will come over here, I value will be 2. Over here we'll check if customer churn dollar gender 2, so this is male again, so count's value will be increased to 2. Similarly then I's value will be 3, and we'll check the cell number 3 over here. Cell number 3 is male again, and again so the count value will be incremented and it'll be 3 now. So this is how this loop will go on. So let me print this over here. Let me print count. So we see that there are 3,556 male customers. So let me verify this with the help of table function. So I'll type table of customer churn dollar gender, and we see that this is actually true. There are 3,556 male customers. Right, so this was for loop. Now we'll go ahead and understand the while loop. Now with the help of while loop, we will get a count of the number of customers whose payment method is electronic check. Right, so now I will delete all of this. I will give a new variable which is I is equal to 0. I will create the while loop over here. I'll give a condition. So I will check if I is less than n row of customer churn. That is, if 1 is less than 7043. So this actually needs to be less than or equal to 7043. And if this is true, I'll go ahead and check my condition. If customer churn dollar payment method, here I'll give the cell number, which will be I. So if this is equal to electronic check, then I will increase the value of count with 1. So count will be count plus 1. Right. So after doing this, I will also increment the value of I. So I will be I plus 1. So let us understand this properly. So I am checking if 1 is less than or equal to 7043, which is evaluated to true. And since this is evaluated to true, then I am using the if condition to check if the cell number 1, the payment method, is electronic check. So since this is electronic check, the value of count is incremented. Now after this if condition is done, I am incrementing the value of I over here. Now I's value will be 2. Then I'll check if the value over here is electronic check or not. Similarly, this loop will continue on. So let me go ahead and select all of this and print it over here. I'll type count. Now let me verify this. So table of customer churn dollar payment method. So see that the number of customers whose payment method is 2365, and over here we have got the count to be 2365. Right, so we are done with while loop. Then we have user defined functions. So these basically help us to modularize our entire program. Let's say if we wanted to find out the minimum and maximum values of every column. So all we need to do is create two functions, min and max, which can be applied on all the columns. So let's go to RStudio and create some user defined functions. Right now, again, I'll create a user defined function to get a count of number of male customers. I will name the function to be gender count. Now this is the syntax of a user defined function. So I will type function, and this is our parameter over here. Right. Now inside this, I need to write the entire code to find out the count of the number of male customers. Right. So I'll be using the for loop again to do that. So I will type for I in 1 is to length of x. Right. And over here, I will check if x of I is double equal to male. And if it is equal to male, then I'll say count is equal to count plus 1. Again, I will create a new local variable over here, count, whose initial value is supposed to be 0. Right. So let's go through this function again. So this is the syntax of a function, and I am naming this function to be gender count. So over here, I will send this gender column as the parameter. Now, once I do that, I have initialized local variable where count is equal to 0. And over here, the loop starts. So for I in 1 is to length of x. So length of x, that would be the length of this column, which would be 7043. So this loop will go from 1 to 7043. Right. And inside this over here, we check for each and every cell. So if x of I, so for first iteration, it will be x of 1. So we'll check for this cell. So if this value is equal to male, then count's value is incremented by 1. Again, I's value is 2. And if the value in the cell is male, count's value is also incremented by 1. And this goes on. After the entire loop is done, I'll also print the value of count over here. Alright, so I will select all of this and I will paste it over here. So we have our function to be ready. Right, so gender underscore count, and I will send the gender column as the parameter. Right, so we get a value of 3556. Let me verify this again. Table of customer churn dollar gender. Right, so we see that number of male customers is 3556. So now The best part of functions is we just need to make a small change over here if we need to find out the number of female customers. So all I'll do is I will change this to be female, and I can pass in the same column to find out the count of number of female customers. Right. So I will use this function again, gender count, and I'll say customer churn $gender. I'm sending this as the parameter. Now let us see the count. Let me verify this. So I will type table of customer churn $gender. And over here we see that the number of female customers are 3487, and that is the same value which we've got with the function. Right, so this was an implementation of user-defined function. We'll work with the basic data structures in R. So we'll start with one-dimensional data structures, which are vectors and lists, and then we'll head on to matrices and arrays, which are multi-dimensional data structures.
So the most basic data structure in R is a vector. It's a homogeneous unidimensional object. So what do I mean by homogeneous? Well, all of its elements must be of same type. Like over here, we have a collection of birds linearly arranged. Now let's go ahead and implement this in R. Alright, so we are back to our studio. I'll start off by creating a character vector, and I'll name it as bird. And I'll go ahead and give down some names of birds. So our first bird would be eagle. Then we have parrot, and our final bird would be pigeon. Now let me print this. Right, and let me also go ahead and check the class of this vector. So I'll type class of bird. Right, so we see that this is a character vector. That is, all of these three elements are actually characters. Now I'll be creating an integer vector, and I'll name this as numbers. So I'll just list down the numbers from 1 to 9. Let me print this now. So this is a vector which comprises of numbers from 1 to 9. Let me go ahead and check the class. So I'll type class of numbers. So this is integer. Then we have a numeric vector type. So in numeric, we can give floating point or decimal values. So I'll name this to be decima, and I'll give some floating point values. So I'll just give some random floating point values over here. Let me print this. Now let me check the class. So I'll type class of decima. So see that this is of numeric type. Right, and then finally we have a logical vector, and in logical vector we can just have two values, either true or false. So I'll name this to be logit 100, and give out some logical values, true, false, and if I'm too lazy I can just give T and F like this over here. Right, so let me print this logit 100. Right, so these are all of the values of this vector. Now let me check the class. So I'll type class of logit 100. So see that this is of logical type. So this was an implementation of vectors in R. So then we have a list. So a list is a heterogeneous collection of elements. That is, the elements do not have to be of the same type, and each element actually retains its own identity even when it is present in the list. Like over here, we have a heterogeneous collection comprising of a bird, an apple, and a car. So let's head to R and work with list. So this is how we create a list. I type out list, and let's say the first element is the integer 1. Then I'll give a character value, and I'll name it to be Nirvana. After that, I'll give a logical value, and this is true. I'll store this in mix bag. Right. So let me print mix bag over here. So this is how our list looks like. So we have three elements. First is integer, next we have character, and then finally we have a logical value. So let me check the class of this object. So I'll type class of mix bag. So you see that this is a list. Now I'll also go ahead and check the class of individual elements. Right, so I'll type class of mix bag, and I'll give two square braces, and I want to check the class of the first element. Right, so we see that it is numeric. Second is character, and the third element is logical. Right, so let me actually print the list for you guys. So this number 1 is of numeric type, This element nirvana is of character type, and this element true is of logical type. So we see that all of these three elements retain their original identity or their original classes. So this is how a list functions. Next in line is a matrix. So matrix is a homogeneous collection of elements in two-dimensional space. So over here, all of the elements belong to the same category, namely fruits, and they are arranged in the form of rows and columns. So now let me go ahead and implement matrix in R. Alright, so to create a matrix, what I'll do is I'll actually be using the same vector first. So let me have a glance at this. Right. So now I'll be inserting all of these elements into our matrix. Right. And to create a matrix, I will type matrix. So the first parameter is the data. So for the data, I am giving the numbers vector. After giving the numbers vector, we have two other parameters where we specify the number of rows and the number of columns that we want. So let's say since we have 9 numbers in total, I would want this to be a 3 cross 3 matrix. That is, n row is equal to 3, or number of rows is 3. And similarly, n col is 3, or in other words, number of columns is 3. And I will store this in mat1. So let me print mat1 now. Right. So this is our matrix over here, where all of these of same type 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are all integers, and I'm storing them in the form of rows and columns. And what you see over here is these elements are arranged column wise. So if I want to arrange these by row, then what I'll do is we have the by row attribute, and I'll just set it to be true. Right. And I'll print mat1 now. You see the difference over here. So now the elements are arranged by row 1, 2, 3, 4, 5, 6, 7, 8, 9. Initially they were arranged with respect to column. Now they are arranged with respect to row. Right. So now I'll create a character matrix. So what I'll do is I'll create a character vector first and list down some characters. So let's say I will give the first 6 alphabets. So A, B, C, D, E, and F. Right. So I have created a character vector naming alpha, and this consists of 6 elements. All right. Now I'll take this vector and create a matrix. Matrix. The data is coming from alpha vector. Now, since there are 6 elements in total, I want this to be a 2 cross 3 matrix. Right, so number of rows is 2 and number of columns is 3. And I will store this in, let's say, mat underscore alpha. Let me print this now, mat underscore alpha. All right, so this is our matrix over here. So 2 rows and 3 columns. Now again, if I want to arrange this with respect to row, all I need to do is set by row to be true. Now again, I'll be printing mat alpha. Right. So this was with respect to columns. This is with respect to rows A, B, C, D, E, F. Right. So we have also created the matrix. Now, what if you wanted to access the individual elements of the matrix? So this is how we can do it. So let's say I would want to access this element over here. So all we have to do is set the index values. So this is present in the first row and second column. Right. So I'll give 1, comma, and we have successfully extracted this element over here. Similarly, if you wanted to extract this element F over here, so this is present in second row and third column. Right. So mat alpha 2, comma 3, and we have successfully extracted the element F from this matrix. Right, so this was an implementation of matrix. And finally we have arrays. So this is just an extension of matrix. That is, it is a homogeneous collection of elements in n-dimensional space. So let's actually go ahead and implement arrays in R. All right, so what I'll do is I'll create a new integer vector.
and give out values from 1 to 9, and I'll create a second integer vector, and in this I will give the value starting from 10 to 18. So we have created two numeric vectors over here, and we'll be using these two numeric vectors to create an array. So this is the syntax to create an array. I'll type array and I'll give out the data, right? So the data is coming from these two vectors. I'll use the combine function and give out these two vectors over here, num1 and num2, right? After this, I need to set the dimensions. That is the number of rows, the number of columns, and the number of dimensions, right? So the dim will be, so in total we have 18 elements. So we have 9 elements in num1 vector and 9 elements in num2 vector. So what I need is actually two matrices of 3 cross 3. So I will give 3 comma 3. So this is the number of rows and number of columns, and since I need two matrices of this type, so I'll type in 2, and I will store this in array 1. Now let me go ahead and print array 1. So this is our resultant array, right? So this is all of the elements from num1 vector which are stored in this part over here, and then we have all of the elements from the num2 vector which are stored in the second dimension over here. Right now, so how can we access individual elements from this? So let's say I would want to access this element number 15. So let's go ahead and access this. I will type array 1. Now let me check where is this present. So this is present in the third row and second column. So I'll type 3 comma 2, and after this, since this is present in the second matrix or the second dimension, I'll give in 2 over here, and let me check the result, and voila. So we have successfully extracted 15 from this. So similarly, if I wanted to extract this element 5, so let's go ahead and do that. So let me actually, yeah, I need this now. So I will type array 1, and this is present in second row and second column. So I'll type 2 comma 2, and since this is present in the first dimension itself, so I'll give out 1 over here, right? And I have also extracted 5. We'll be working on a project. So this project would be on recommendation engine. So have you ever wondered which book to read next? Well, I often have, and to me, book recommendations are a fascinating issue, and that is exactly what we're going to do today. So our dataset for the case study comprises of these 4 files: ratings.csv, books.csv, booktags.csv, and tags.csv. So as the name suggests, ratings.csv contains all users' ratings of the books. So there are a total of 980,000 ratings for 10,000 books from 53,424 users. So the books.csv contains more information on the books, such as the author's name, publication year, book ID, and so on. Then we have the booktags.csv file. So this file comprises of all tag IDs users have assigned to the books and the corresponding tag counts. So the tag IDs basically denote the categories into which the books fall into, and the counts denote the number of books belonging to each category. And we have the tags.csv file. So this file contains all the tag names corresponding to the tag IDs. That is, it gives out the labels corresponding to different tag IDs. So these are the tasks which you'd have to perform in this project. So in the first phase, we do a bit of data cleaning. So we'll start off by removing the duplicate ratings. That is, there are cases where a user has rated the same book more than one time. So we'll go ahead and remove all these instances. After which we'll go ahead and remove those users who have rated fewer than 3 books. Right guys, so we are into our studio now. So let us go ahead and load all of the packages required for our case study. So these are all of the packages required. Right, now after which I'll load the 4 files from our dataset. So these are the 4 files. So we have books.csv, ratings.csv, booktags.csv, and tags.csv. And I'm storing this in objects books, ratings, book tags, and tags.
So we have loaded these 4 files. Now let us have a glance at these 4 files. So I'll be using the view function to have a glance at our 4 files. Right, so these are our data sets, guys. So we have the ratings dataset, which comprise of these 3 columns: book ID, user ID, and the rating. Then we have the books dataset, and these are the columns. So it has ID, book ID, work ID, ISBN, the author's name. Then we have the original publication year, original title, language code, and so on. After which we have the book tags. And here the columns are Goodreads book ID, tag ID, and the count. And then we have the tags dataset. Here we have the tag ID and the corresponding tag name for that tag ID. Right. So as part of our first phase, we had to do a bit of data cleaning. And the first task of our first phase was to remove all of the duplicate ratings. And to do that, we'd have to find out how many times has one single user rated one particular book. And this would be the command for that. So here what I'm doing is I am grouping this ratings dataset by user ID and book ID. After which I am using the mutate function and I'll add a new column to this, and that new column would be given by the n function from the deployer. So this basically would give us the number of times a single user has rated one particular book. And I'm giving the name of the new column to be capital N, and I'm storing the result back to ratings. So let me have a glance at ratings now. View of ratings. So we see that a new column has been added. So this is the user number. So the user number 314 has rated the book number 1 only once. Similarly, if we take this case over here, the user number 2900 has rated the book number 1 only once. So let me go down and see if there are some changes over here in the count of n. Right, so let's have a glance at these two cases over here. So the user number 4206 has rated the book number 8945 two times over here, right? So these are the duplicate ratings which I'm talking about. So these records need to be removed, right? Right, so now let me also use the table function to find out the distribution of these duplicate ratings. So I'll use table function and I will give in ratings $n over here, which would give me the count of the different ratings given by one particular user to one particular book, right? So this value over here tells us that there have been 5 instances where one particular user has rated the same book 5 times. This tells us that there are 28 instances where the same user has rated the same book 4 times. This tells us that there have been 156 instances where the same user has rated the same book 3 times. And this tells us that there are 4,298 instances where the same user has rated the same book 2 times. And this is all of those cases which are not duplicate. That is, the user has rated that particular book only 1 time. Right. So now what I'll do is from this ratings data set, I will filter out all of those duplicate records and I will store them in a new object. So I will put in the name of the dataset, which would be ratings over here, and I will use the filter function to select all of those records where n is greater than 1. That is, which have duplicate ratings, and I will store it in a new object. So we have successfully created this new object. Now let me have a glance at this view of duplicate ratings. Right, so there are 4,487 entries in total which have duplicate ratings. Or in other words, there have been 4,487 instances where the same user has rated the same book more than 1 time. Right, now we'll go ahead and remove all of these duplicate ratings. Now this is a very simple command to do that. So from the ratings object, all you have to do is filter out only those records where the value of n equals to 1. So this basically means that we are filtering out those records where one particular user has rated one particular book only once, and I am storing this result back to the ratings dataset. Right, so we have done the changes. Now let me have a glance at it. View of ratings. Right, so these are all of the records where there are no duplicate ratings. So our second task was to remove all of those users who have rated fewer than 3 books. So for this, we'd have to start off by grouping the users with respect to user ID first and find out the number of ratings given by each user. So I will select this command over here and I'll paste it over here. So I have given ratings over here and I'm grouping this ratings with respect to user ID. After which I am using the mutate function, and over here again I am adding a new column, and that new column would be ratings given, and I will get that ratings given column with the help of this n function from the deployer package. So this n function from the deployer package would basically give me the number of ratings given by each user. Right, so I will store this back into the ratings dataset. Now let me have a glance at it. View of ratings. So this is the user ID. So the user number 314 has given 181 ratings in total. The user ID 439 has given 173 ratings in total. Similarly, the user ID 9246 has given 190 ratings in total. So now we'll go ahead and remove all of those user IDs who have given less than 3 ratings. So this is the command for that. I have again given ratings over here and I am filtering out only those records where the ratings given by each user is greater than 2. That is, each user has at least rated 3 books or more, and I am storing the result back to ratings. So view of ratings. So this is our final data set. So we see that there are 960,595 entries in total. So we are done with the first phase. In the second phase, we'll do some data exploration. So we'll start off by extracting a sample set of 2% records from the entire data set. Then we will make a bar plot for the distribution of ratings. That is, we'd want to analyze the count of different ratings. After which we'll make a plot to understand how many times each book has been rated. Then we'll make a plot for the percentage distribution of different genres. Going ahead, we'll find the top 10 books with highest ratings. And finally, we'll find out the 10 most popular books. Right, so we are back to our studio again and it's time for phase 2 now. So the first task in our phase 2 was to select a sample from the entire data set. So I'll go ahead and set a seed so that if I ever want to run these commands again, I can get the same results. So I'll set the seed value to be 1. And I'll set a user fraction of 0.02. That is, from the entire user base, I need only 2% of the sample users. So I am assigning this value of 0.02 to a new vector and naming that new vector to be user fraction. Now after which I will find out all of the unique user IDs. So I am using the unique function over here and I will give in the user ID column from the ratings dataset. So this will give me all of the unique user IDs and I am storing the result in the users object. Now after this, let me have a glance at the number of the unique user IDs. So length of users. So we see that there are 45,016 unique user IDs in total. So we need 2% of these unique user IDs. So 2% of this would be 0.02 into 45016. So this would give us 900 users. So from 45,016 users in total, we would need 900 users. Right. So we'll do a random sampling of 900 users from the entire user base. So this is the command for that. So I am using the sample function and this is the list of all of the users. And from all of the users, I only need 900 of the users. So earlier we had multiplied the user fraction into the length of the users, which gave a value of 900 point something. So we are basically rounding that off. And I will store that result in sample users. So now let me have a glance at the length of sample users over here. Length of sample users. So we see that there are 900 sample users in total. Now let me also have a glance at the number of ratings. So initially the number of ratings which we have is 9,60,595. So now what I'll do is, from this ratings data set, I will be filtering out only those user IDs which are present in the sample users object. That is, I would need only the sample users from all of the users. And I will store the result back to ratings. Right, now let me have a glance at the number of ratings. So in row of ratings, so now we see that the number of ratings has reduced to 18,832. So initially we had more than 9 lakh ratings. So now after filtering the data set, we have just 18,832 ratings. Alright. So our second task was to make a distribution of these ratings. So let me go ahead and do that. So guys, this is the command for that. So again, I am using the ratings data set, and on top of this, I am building the ggplot. So here, I am mapping the rating column onto the x-axis. So this column over here, so we have different ratings, 1, 2, 3, 4 and 5. So I am mapping this column onto the x-axis. So the fill color would also be determined by the rating column. And after that, since we'd have to make a bar plot, I am using the geom bar function. And the color which I give to the boundary of the bar plot would be gray 20. And the color which would be coming to all of these bars would be from this palette over here. So the palette is YLGNBU. So this stands for yellow, green and blue. So we'll be giving this inside the scale fill brewer function. Right. And I am also setting the guides to be false. Let me hit enter. So this is what you get. Let me zoom this now. So this is quite an interesting plot, isn't it? So let's have a glance at this bar over here. So this basically tells us that there are more than 6,000 cases where a rating of 4-star was given. Now similarly, we see that there are more than 5,000 cases where a rating of 5-star was given. And this bar over here, so this tells us that around 4,700 times a rating of 3-star was given. So the count of these two bars is quite low. So there have been very less cases where a rating of 1-star was given. So maybe not even 500 times a rating of 1-star was given. So this is for the rating of 2 stars. So around 1,000 times rating of 2 stars would have been given. So guys, this is the distribution of the ratings. Now after which we had to find the number of ratings per each book. So let's also do that. So here again, I start off by giving the ratings data set, and I would have to group this with respect to book ID because I'd want to find the number of ratings per each book. So that is why I am grouping it with respect to book ID. Now after grouping it, I will use the summarize function. So basically inside this summarize function, I will basically get the count of number of ratings for each book. So here I am again using the n function. So this n function would give me the number of ratings per each book, and I'm also naming the result to be number of ratings per book. After which I'll again use the pipe operator and add a layer of the ggplot on top of it, and I am assigning the number of ratings per book onto the x-axis. The fill color is orange, the boundary color is gray 20, and the x-axis values would range from 0 to 40. Right guys, so this is the plot. Let me zoom this now. So from this graph, we can basically infer that there is not even one case where a book was rated more than 10 times. So let's have a glance at this bar over here. So this tells us that there are more than 2,500 instances where a single book was rated only by one user. So this is for those instances where a single book was rated by 2 users, or in other words, a single book was rated 2 times. This is for those instances which tells us that a single book was rated by 3 users, or in other words, a single book was rated 3 times. And the count for this is around 1,500 times. Right, so this plot was for the number of ratings per each book. Then we had to get the percentage distribution of the different genres. So what we'll do is we'll start off by making a new object and giving it the name genres. So this genres object would basically have a list of different genres in it. So I have basically listed down a bunch of different genres over here, and I am storing all of these into the genres object. So the different genres are art, biography, science, thriller, travel, humor and comedy, and so on. So after building the genres object, what we'll do is, from this tags data set, I will be extracting only those tag names which are present in the genres. Or in other words, I am extracting only those genres which are listed down over here. So this is the command for that. So what I'm basically doing over here is, I am finding out if the listed genres are present in the tag names or not. And if they are present, I am extracting only those genres and I am storing them in available genres. So let me hit enter and let me actually see what are the available genres. Right, so these are all of the available genres in the tags dataset. So there are 27 genres in total, and these are Christian, business, poetry, philosophy, science, and so on. Now similarly, I will extract all of the corresponding tag IDs with respect to the tag names. So let me find out which are the available tags. So over here, I am basically extracting all of those tag IDs if the tag name is present in one of the available genres, right? So if the tag name is present in one of the available genres, only those tag IDs I'm extracting. And similarly, if the tag name is not present in the available genre, then I won't be extracting those tag IDs. And I am storing the result in available tags. So next we have to make a plot for the percentage of each genre. So let's go ahead and do that. So before we do that, let's actually get a count of the different genres available. So this would be the command for that. Let me print it over here. So what I'm basically doing over here is, from the book tags dataset, I am extracting only those tag IDs which are present in available tags. And then again, I am grouping it with respect to the tag ID. After which I'll use the summarize function and get the number of counts of each of these tag IDs. Or in other words, I'll get the count of the different genres. So let me hit enter and let me see what do we get. So this is the tag ID 2938. And for this corresponding genre, the count is 436. That is, there are 436 books belonging to this genre. Similarly, this is the tag ID 4605 and the count is 1109. So this means that there are 1109 books present for this particular genre over here. And let's take this over here. So the tag ID is 7778 and the count is 469. So this means that there are 469 books present with respect to this genre. Now let me go ahead and also find the percentage. So let me select all of this code over here. Right. So now we had run the command till here. Now, so we basically got the count of each genre. Now, after getting the count of each genre, I am ungrouping it again. After that, I will use the mutate function and find the total count. That is the total count of all of the genres combined. And I am also creating a new column percentage. So this percentage over here, I am dividing n upon sum of n. That is, this would give me the percentage of each of the genre. And after getting the percentage of each of the genre, I will arrange the data set in descending order. And after arranging the data set in descending order, I will also left join the tags data set to the book tags data set. And the joining would be done by the tag ID column over here. So let me store this in a new object. So let's say book info. Now let me have a glance at it. View of book info. Right. So guys, this is the tag ID. This is the count of the tag ID. That is the number of times this genre is present. And this column gives us the total count of all of the genres. This gives us the percentage of the genre. And this is the tag name, which is fantasy. So we've got our data set ready. Now we'll go ahead and make a plot on top of this. So now let me go ahead and make a plot. So the object name was actually book info. So let me change this to book info over here. And on top of this book info object, I am adding a ggplot layer. So here I'll be mapping the percentage column onto the y-axis and the tag name column onto the x-axis, and the fill would be determined by the percentage column. And since we'd want to make a bar plot, we'll be using the geom bar function, and the stat which I've used is identity. And I'll also use the quad flip function over here because I'd want these bars to be stacked horizontally and not vertically. And the color to these bars would be determined by this palette over here. So this is YLORD. So this would be for yellow, orange and red. And the label which I've given for the y-axis is percentage, and the label which I've given for the x-axis is genre. Let me hit enter. Right guys, so this is the plot. So here I have mapped genre onto the y-axis, percentage onto the x-axis. So we see that fantasy is the most prevalent data set, or in other words, most of the books belong to the fantasy genre, and the least percentage is of the cookbooks. So this was the distribution of the percentage of different genres. So up next we'll go ahead and find the top 10 books with highest rating. So this would be the command for that. So if you have to find out the top 10 books with highest rating, all we have to do is arrange this average rating column in descending order, and that is what we are doing over here. So here I have given the name of the object, which is books, and I am arranging this data set in inverse order of average rating, after which I am selecting just the top 10 records, and the columns which I'd be selecting are title, ratings count and average rating. So let me store it in top 10. Let me have a glance at top 10 now. Right guys, so these are the top 10 highest rated books. So the Complete Calvin and Hobbes is the book with the highest rating. So it has the highest average rating of 4.82. And then we have Words of Radiance. So it has a rating of 4.77. Third in place is the Harry Potter box set, which has 4.77 rating. Fourth is ESV Study Bible, which has a rating of 4.76. Fifth in the list is Mark of the Lion Trilogy, which has an average rating of 4.76. Right guys, so we have successfully found out the top 10 books with highest ratings. Next we'll go ahead and also find the top 10 most popular books. So this would be the command for that. So to find out the top 10 most popular books, we'd have to arrange this ratings count column in descending order. That is, whichever book has the most number of ratings, it would automatically mean that it is the most popular book. Right, so this is the command for that. Let me run it over here. So here what we are doing is, on the books dataset, I am arranging it in inverse order of the ratings count column, and then I will be extracting the top 10 records, and I'll be selecting the title column, the ratings count column and the average count column. So let me store this in top popular. Let me have a glance at top popular. Right, so these are the top 10 most popular books. So the most popular book in the list is The Hunger Games, which has the highest ratings count. Then the second most popular book is Harry Potter. Third most popular book is Twilight. And the fourth most popular book is To Kill a Mockingbird. In the third phase, we'll finally do some recommending. So we'll start off by building the user-based collaborative filtering model. And then we'll recommend 6 new books for 2 different readers. Right guys, so it's finally time to recommend some books. So before we go ahead and do that, we'd actually have to restructure our data a bit. So our data actually needs to be in the form of a matrix where all the rows should correspond to the users and all the columns should correspond to the books. So the dimension names would then nothing be but the user IDs and the book IDs. So the user IDs would represent all of the rows and the book IDs would represent all of the columns. So let me go ahead and extract all of the dimension names first. So here with this command, what I'm doing is I am extracting all of the unique user IDs, and I'm also extracting all of the unique book IDs, and I'm storing them in this object dimension names. So this is our first task. So we have basically got all of our dimension names. Now we'll go ahead and convert the format of our data frame from long format to wide format. So with this command, what we are doing is we are actually selecting the book ID, the user ID and the rating columns from this data frame over here. And I'll be splitting this book ID column. That is, this value of book ID 1 would become one column. This value of book ID 2 would become the second column. This value of book ID 3 would become the third column, and so on. And these rating values over here, they would become the values for the corresponding book IDs. So this is how we can use the spread function to spread out our data frame from long format to wide format. And we'll also remove the user ID column because it doesn't serve a purpose, and I will store it in a new object and name that object to be rating mat. So let me hit enter. Right, so we have created our rating matrix. So we have created the rating mat object. Now let me have a glance at the class of this. So class of rating mat. So we see that this is still in the form of a data frame, but we can build our user-based collaborative filtering model only on top of the real rating matrix. So first we'll have to go ahead and convert this data frame into a matrix. So let me do that. So here with the help of as.matrix function, I am converting the class of rating mat from a data frame to a matrix, and I am storing the result back to rating mat. Right. So now let me have a glance at the class. So class of rating mat, and we see that now it is a matrix. So let me have a glance at the first 5 rows and the first 5 columns of it. So these are the first 5 rows and these are the first 5 columns. So we see that this user ID column has not been removed. So let us go ahead and manually remove these. So what I'm doing is I am manually removing this first column and I am storing it back into rating mat. Now let me have a glance at first 5 rows and first 5 columns. Right. So these are the first 5 rows and these are the first 5 columns. So these rows basically correspond to all of the user IDs and these columns basically correspond to all of the book IDs. So these NA values which you see over here, so this basically means that the first user has not rated the first book, the first user has not rated the second book, similarly the fourth user has not rated the third book, and so on. Right, so we have our rating matrix ready. Now let me also assign the dimension names to the dimension names of this rating mat object. So here I am assigning all of the dimension names which I've extracted to the dim names of the rating mat. Right. So now let me have a glance at the dim names of rating mat. So dim names of rating mat. So these are all of the dimension names for the rows. So this is the name for row number 1, this is the name for row number 2, and this is the name for row number 3. So this basically signifies that all of the rows are represented by the user IDs. Similarly, if I go down, then we have all of the book IDs. So all of the columns are represented by the book IDs over here. Now let me use the dim function to find out the number of rows and columns in the matrix. So we see that there are 900 rows and 8,431 columns. Or in other words, there are 900 users and 8,431 books. So we have got our metrics ready, but we can't just build a user-based collaborative filtering model on top of the metrics. So we have something known as a real rating matrix. And the recommender lab basically works only on this type of object. So I will store this rating mat into a new object and name that object's name to be rating mat 0. Let me again have a glance at the number of dimensions of this. Dim of rating mat 0. So we have the same number of rows and columns. So again here, the number of rows are 900 and the number of columns are 8431. Now after this, what we'll do is, wherever we have NA values, we will replace those NA values with 0. So in rating mat 0, wherever we find NA values, I am replacing those NA values with 0. So now let me again have a glance at the first 5 rows and the first 5 columns of this. So it'd be rating mat 0, 1 to 5 and 1 to 5. So we see that all of the NA values have been replaced with zeros. So now we can go ahead and convert this matrix into a sparse matrix. So I'll be using the as function, and I am converting this rating math 0 object into a sparse matrix, and I will store this in a new object and name that object to be sparse ratings. Now let me again have a glance at the first 5 rows and first 5 columns of this. So sparse ratings 1 to 5 and 1 to 5. So this is how a sparse matrix looks like. So basically with the help of a sparse matrix, we end up saving a lot of space. Now it's the last part of the transforming. So we will go ahead and convert this sparse matrix into a real rating matrix. So for this we would need the new function, and with the help of new function I am converting this sparse ratings object into a real rating matrix. So this over here takes in two parameters. So the first parameter is basically what we are trying to convert this into, and then we given the data which we are trying to convert, and I'll store this result in real ratings object. Let me print real ratings now, and let's see what do we get. Real rating. So this is what we get. So it is a rating matrix where there are 900 rows and 8431 columns, and it is of class real rating matrix with 18,832 ratings. Right. So we finally have our real rating matrix ready. So now we can go ahead and build a model on it. So what we'll do is we'll go ahead and split the data set into train and test sets. So it'll be a 80-20 split. So I'll be using the sample function to create this 80-20 split over here. So I am using the sample function, and I will generate true or false values over here, and this sampling would be with replacement, and the probability is 80-20. That is, I would want to divide the data set into two parts, where the first part would comprise of 80% of all of the observations, and the second part would comprise of 20% of the rest of the observations. And I will store the split criteria in a new object and name that object to be split book. So now in real ratings, wherever the value of split book is equal to true, I will select all of those records and store those records in rec train. Similarly, from the real ratings matrix, wherever the value of split book is assigned to be false, I am extracting all of those observations and storing those observations in rec test. So we have our training and testing sets ready. Now we can finally go ahead and build our first model. So we'll be using the recommender function, and this over here takes in two parameters. First is the training set on which we'd want to build the model, and next is the method or the type of the recommender model which we'd want to build. And since we'd want to build a user-based collaborative filtering model, we'll given the type to be UBCF. So if we wanted an item-based collaborating filtering model, then the method would be IBCF. But in our case, since we want user-based collaborative filtering model, so the method would be UBCF, and I will store the result in an object which would be rec model UBCF. Right, so I have successfully built the model. Now I'll give a value for the number of books to be recommended. So I am assigning the value 6 to a vector, and the name of that vector is unrecommended UBCF. So this basically lets us know that we'd have to recommend 6 books in total. Right, so the model building process is done. So let me go ahead and predict the values. So I'd have to use the predict function for this. So over here, this takes in 3 parameters. First is the model which you built. Next is the dataset on which we'd want to predict the values. And third is the number of values to be recommended. Right. So first we'll given the model which you built, which is rec model UBCF. And then we'd want to predict on top of the test set. So the test set is rec test. And the number of books to be recommended is 6, which is stored in unrecommended UBCF. And I will store this result in rec predicted UBCF. Right, so the prediction is also done. Now let me go ahead and find out the item numbers which have been predicted. So now that we have predicted the values, let's go ahead and recommend some books to user number 1. So here we will use this object rec predicted UBCF. So this is the object which we've just built using the predict function. And I'd want to find out the item numbers which have been recommended to user number 1. So this command over here, rec predicted UBCF at the rate items 1. So this will give me the column numbers which have been recommended to user number 1. So let me have a glance at user 1 book numbers. So this basically means that user 1 has been recommended to read these books which are present at columns 2177, column number 6343, column number 423, column number 1908, column number 2274 and column number 2514. Now we just have the column numbers. So let's actually find out the labels for these column numbers. Right, so from rec predicted UBCF, we have the item labels, and inside the item labels, I will give in the book numbers which have been recommended. Right, so these are the item labels. So the book ID, which is under column number 2177 is 2636. The book ID, which is under column number 6343 is 7482. Similarly, the book ID, which is under column number 2274 is 2750. So we have successfully got the book IDs. So now that we have the book IDs ready, let's actually use these book IDs to extract the name of the book and the name of the author. Right, so what I'll do is I will extract the title of the book and the author's name where the book ID is 549. So the name of the book is Corduroy and the author's name is Don Freeman. Similarly, let me extract the title and the author's name where the book ID is 2750. So here we see that the book recommended is Mrs. Pigglewiggle and the authors are Betty McDonald and Alexandra Boyger. Similarly, let me extract the titles for the book ID 3029. Let's see what do we get. 3029. So the book recommended is Rage of Angels and the author is Sidney Sheldon. Right, so these are the 6 books which have been recommended, and this is how we can extract the name of the book and the author of the book. Now similarly, let's also go ahead and recommend 6 books for the user number 5. So this is what I'd have to do. I will be using the rec predicted UBCF object, and I'll be using the @tag and extracting the items for user number 5. And I'll store this result in user 5 book numbers. So now that we have the item numbers, let's actually extract the column numbers for each of these items. So for this, the command would be rec predicted UBCF @item labels. And inside this, I will give in the book numbers. Right, so these are the book IDs which have been predicted. Right, so similarly, let's extract the title and authors for some of these book IDs. So we are extracting the title and the author's name where the book ID is 4624. So the recommended book, so the name of the recommended book is The Girl Who Circumnavigated Fairyland in a Ship of Her Own Making, and the author is Catherine M. Valentine and Anna Wan. Similarly, let's extract the name of the book and the author's name where the book ID is 6867. So here the book is Malgudi Days and it's been written by R.K. Narayan and Jhumpalari. Now let me extract the title and the author's name for the book ID, which is 7326. So the book's name is Doctors and it has been written by Eric Segal. Right guys, so we have successfully implemented the user-based collaborative filtering model, and we have recommended 6 books to 2 different users.